Okay. All right. So I'm gonna start. This is a demo we put together for IBC back in September. Cinemedia, Akamai, and Özyeğin University. So we are gonna talk about what we did to make this work, and one of the first implementations, probably the first implementation of fetch in MoQ. And this is what's really happening here is an event timeline and using MoQ for past media. So not just for live media, but we can use it for past content as well. So the demo is going to be on this website. It has been running since August, and we are going to show a live demo as well. So let's look at this. Since this is the first MoQ talk, I thought this slide will be useful. Quick is the fundamental transport protocol underneath MoQ transport. Quick is really like it's supposed to be a replacement for TCP, which has been running for over 4 decades in the internet. It is running between a sender and receiver or server and client. It is really like a multi-lane highway. So it's a single connection, but there could be multiple simultaneous, parallel streams running at the same time. So over these streams, you can transmit different data depending on your application requirements. One of the important things about Quick is that it runs in the user space. So it is going to be within your application, like in your Chrome browser or in your MoQ application and so on. It has its own congestion control algorithm implementation. You can customize it depending on your needs as well. So among these streams, there could be prioritization, which is one of the most useful features for MoQ. There could be high priority audio traffic, for example, medium priority screen sharing, and then low quality like video and chat and other stuff, right? And streams are guaranteed to be delivered, reliably and in order. But among streams, obviously, there is no guarantee for delivery. And streams can be canceled anytime by the receiver or by the sender, so that if some data is not going to make it by its deadline, you don't need to transmit it at all. So that's a useful feature. And everything in Quick is encrypted. This is important. And the network operators cannot actually see what's really happening or transmitted in your MoQ traffic. So you want to go over this?
Yeah.
Yep.
So what is it? It's like this. Yeah. So yeah, about MoQ. So we need to make a distinction between, MoQ is a working group at the IETF. MoQ-T is the protocol that has been defined on top of Quick to transport multiple tracks, multiple media tracks across multiple relays. So this is something which was at the core initiative of MoQ, to have the relay being an identified entity which has some specific role in the protocol. This is something which is a bit unusual in the network. We have to tend to do server clients. Here the relay exists, and this is something which matters. And we have as many media tracks as we want, which is a very important feature if we consider how many new audio, subtitles, metadata we will have to carry today. And we have some control streams which allows the subscribers, the relay, and the publisher to subscribe to the tracks, to publish tracks, to announce tracks. So this is something which is a global media delivery plus signaling protocol. Okay, so it can work either on web transport and raw Quick. The main point of web transport is that it's a state-of-the-art technology stack, network stack, which is so it embeds a lot of new features for security, typically multiplexed bidirectional real-time transport. So MoQ-T, it's something which has started like more than 2 years ago. So people start complaining about the fact that we don't converge to a final draft, but I believe we are converging. There is no consensus on this. We are at draft number 16, so there is a consolidated amount of work on this. There are many software which interoperate for this. We have more than 1,400 issues that have been heavily discussed. So it's something which is a very active group. And in the meantime, we have on MoQ streaming format, so MSF, and it's a companion CMSF for the CMAF transport. So think about MSF as being all the ways to implement media streaming for the media streaming industry, how to apply MoQ and to build a streaming system based on MoQ. So we added into the MSF, and mostly Will, who is the author of this, a lot of different elements like catalog, timelines, packaging, tokens, which are significant ingredients of the streaming industry today, but they are not part of MoQ, but we apply MoQ technology for this.
Okay. So MoQ is really about unifying real-time communications and content delivery. Today we have -HLS for on-demand or live streaming, and WebRTC for real-time applications. So scalability is way better for -HLS, obviously, but then responsiveness, interactivity is better for WebRTC, and MoQ is actually meant to marry these two words together. So on one hand, we have the subscribe API for low latency delivery for live events, and then we have fetch, which is the subject for today's presentation for past content. It could be just time-shifted content, or it could be just a VOD file.
We are doing multiplexing here, as you can see. So we need to introduce one MSF points, which is a timelines. So we have a media publisher, which generates constantly some video flow. And we standardize in MSF something which is called the media timeline. So the media timeline is a MoQ track, which transport not media, but textual information. And in this information, we have three elements. One is a media PTS, one is the wall clock time, and one is the MoQ group ID and object ID, which is called MoQ location. Okay. What is the media timeline? It allows the subscribers, the receivers of this, the consumer of the content, to synchronize the MoQ group and object that it receives with some media PTS and some wall clock time. What is important is that from this, you can build other kind of timeline tracks. Okay, so one example of it is an ad event timeline, where you will use one of the three indices of the media timeline. So here it sees the wall clock time, and you will add your own data just after this. So typically for an ad, it would be a SCOTY 35 marker saying, hey, you need to introduce an ad at this time of the stuff. And so the subscriber of this will receive the information. It will be able to detect how the wall clock time corresponds to which MoQ group, and it will be able to do a smooth continuity for the ad insertion. And the other one that we used for this demo is a sport AI metadata. So we run a 6-floor plugin, which is something which analyzes live the video data, okay, for the sport, and you can identify if there is a goal. So here is a goal for France, red card for England, and end of the game. Just a random example, okay? And it associates this information to the MoQ group on MoQ location, okay? And this is what we will use for this. So all of this goes into a catalog, which is something which has been defined in MSF as well. And in the catalog, you have the media timeline, you have the ads, and you have the AI stuff. And so the consumer receives the catalog and can decide to subscribe to whatever he wants. So typically, the guy on the top is interested only in the ad, and the guy on the bottom is interested to consume the AI metadata stuff. So it's a way to multiplex it and to send all the data. So a quick genesis of the demo. So we have to thank Zafer because everything was based on Zafer works. He made during the IETF meeting a demo about how to use Fetch. But the demo was about like a video conferencing, and we could be back on the video conferencing stuff to say, hey, you say that, you told this. So that was cool, okay? And then it was a party. And during the party, we had a lot of mocktail, okay? And we say, okay, probably we can do better. We can have a more entertaining, time-shifting scenario. And so we start thinking about this gaming stuff. We call Will, of course, because we wanted to build on MSF and because we wanted to have free servers as well.
It wasn't called MSF at that time, but...
it was called Warp at that time. We called the AI guy Sixth Floor, which is a Portuguese company which does this event generation. And September 14th, we had a demo. So it only took us 2 months to do this. So either it's because the protocol is already mature, or because Zafer is very good at programming, probably a boss of both. So it's possible, based on what we have in MoQ, to build already cool demo and proof of concept. This is what we wanted to say.
Okay. So quickly, this is what the architecture looks like. We have a live game. Of course, this is a pre-recorded game, but through FFmpeg, it's a live source. And then it's being live encoded. It goes to this AI engine where all these points of interest are determined and then fed into the MoQ publisher, which is creating an event timeline, as you can see over there. And then it goes to a relay and then eventually the player, right? We can have as many players as we like. And then this is what we are going to show. So let's switch to the demo now. Unfortunately, I'm not going to manage it here. Zafer is going to run it here. So if you go to ibc'25.moqtail.dev, we are going to see this interface. We have 2 relay and publisher locations at this point. So we are closer to Chicago. We can click on it. And then the game is going to start. So a couple of things here. So this is obviously, again, a pre-recorded video, but we are live sourcing it from FFmpeg. So on the top left corner, you see how long it has been since the game has started, 32 minutes, 15 seconds, and some milliseconds. Publisher time is the Chicago local time, and the subscriber time is our time in here. And the difference is 0.6 seconds live latency. So by the time the media is encoded by FFmpeg, and then it is displayed here. That's exactly 670 milliseconds right now. So you see the timeline over here at the bottom. So there are some plays, some 1-point shots, 2-point shots, 3-point shots, and so on. You can filter them as much as you like. And in case you miss something, this is the live feed. So Zafer, let's click one of those. I guess there's a 3-point shot over there. Let's say you had a pit stop and you missed it, and then you want to see this replay again, and the live still continues, and then you see the replay. You can open as many, like 16 replays simultaneously, and so once the replay is done, you go back to the live, right? It comes back to the main screen. Now let's open the settings, Zafer. I just want to show you what you can do with this. So you can set the target latency here. Now it is 750 milliseconds. We are only 100 milliseconds away from Chicago, so we can actually set the latency around 200 milliseconds. So it's like real time, and make it work depending on the Wi-Fi here. Latency tolerance is like plus minus values from that target. And then the playback speed range is really like when we want to catch up with the target latency, or if we are ahead, we want to slow down. That's the playback speed we are going to allow. So close that window, Zafer. And then on the right-hand side in the middle, you see the statistics. Over there. You can enable them or disable them through the menu over there. And you see some buffer, playback ratio, all kinds of statistics while you are watching this. So this demo is available. I mean, it has been running over 6 months now on the website. Again, there are 2 locations, Amsterdam and Chicago. They are publishing the same game. And, all this data is also, the event timeline. 6th Floor does it in real time, but again, this is just pre-recorded. But event timeline is broadcast in real time so that the client feeds this information. At the moment, we allow only for the last 10 minutes to show up in the event timeline, but it's customizable. And in the future, if you want to, we can actually turn this into a fully seekable bar, so you can go back and fetch any location you want. There's audio as well. It's in Portuguese. If anybody speaks Portuguese, you can listen to it. And once we are doing replays, the replay audio comes up and the live broadcast audio is dimmed a bit so that it is audible. Anything you want to add?
No, it's good.
All right. Can we go back to the slides? Okay, so, and then everything regarding this demo, the source code and, the publisher, the relay, and the player, they're all on GitHub open source. So what we really achieved with this demo is unifying abstraction. So there are multiple things happening here, like a live broadcast as well as on-demand, time-shifted playback. It's a single transport within a single quick connection. Optimization for latency, we can show a couple of hundreds of milliseconds live broadcast latency, nothing we could achieve with low latency dash or HLS. And then simplification of infrastructure. Again, everything is done over a single relay, over a single connection, and that simplifies a lot of things. So this is based on our mocktail implementation, our open source reference implementation. We are at draft 14 now. Draft 16 just came out a couple of weeks ago. We are not at 16 yet. There are other demos, including that time travel that Gwendal has mentioned on the website. You can check the source code as well. So yes, that's it. Thank you very much.
Cool. Cool work, cool demo, cool protocols. Let's see whether we have any questions. Okay.
It is always risky to do a live demo, but I'm glad that this one worked.
I was just wondering, what about ABR?
How long do you have for the answer? So I will switch to a quick
it is one of those
answer.
1,400 issues.
Yeah, well, 10 of them. So next week, Monday and Tuesday, we have the IETF interim meeting in Boulder, which is just closed. And I think we will spend like more, 2/3 of the time discussing this. So we propose something which is called Switch, which is a new API, which is triggered by the subscriber, but executed by the relay. So the client would say, I want to switch, and the relay will make sure that there is no gap and no extra bandwidth spent on this. So it would enable something which is close to the client-side ABR that we know, but we could also use it to zap from one channel to another or change audio from one to another. So other kind of scenario, and there are a lot of discussions about server-side ABR, so meaning that the publisher or the relay could switch based on the measurements it has, and there is no consensus on the API yet. But we hope that Wednesday we will have.
The client-side switch is also on the website as a demo. So
Okay, yeah, I just wondered whether the demo had like ABR in it.
this one didn't.
Okay.
This is a single bitrate.
I see, right, okay.
Yeah.
Okay, fine. And then just, I don't know, can I ask another question?
Right.
Just on the relays, is there sort of rate control at all or anything? Just from the talk yesterday about the Netflix sort of setting a rate for your connection, I wondered whether that was a thing that might be possible on the relay, or whether you just do it on like the socket. Well, I don't know, kind of.
That's definitely a potential idea, but at the moment, as soon as the data starts coming into the relay, it starts going out to the subscribers.
Yeah, I guess it's just whether you want it.
It's
you set pacing, like setting pacing rates for the flows.
It is It is particularly true for fetch, because fetch might completely use all your bandwidth. The rest of the time, since we are close to the real time, we deliver with the video bitrate, but we can improve stuff there for sure.
Okay. Thanks.
Just one thing for the fetch. Yes, we do pacing, but fetch is also lower priority than the real-time tracks. So it's not going to actually consume all your bandwidth. The main live track is going to go first before the fetch goes in. Yeah.
Yeah. So in addition to Monday, Tuesday, next week of the MoQ entire meeting, Thursday, Will is hosting a brainstorming session on the MoQ streaming formats here.
Question: can you share the bitrate and the resolution that was?
This was it 2 megabits per second, Zafar?
It's
1, 2,
we don't see your hand, Zafar.
2.
Yeah,
Okay.
this was awful, I know. But we had to, we have to go with sports rights. So there are some people who are sports rights. Yeah.
This was 1080p resolution.
No, it was 720p.
720p, 2 megabits per second. So the quality is not great, I admit.
Sure.
But MoQ has nothing to do with that. So.
Yeah.
And it also helps reduce our AWS expenses. Because they charge for outgoing traffic, unfortunately.